So we're discussing parabolas that have roots of x equals -1 and x equals 4/3. And the first thing we wanted to decide was how many parabolas do that. Turns out many. Any parabola you dream of that you can draw through these 2 points, you can just keep stretching and shrinking it or flipping it, and you can get a whole family of parabolas. So there's infinitely many parabolas that will have these 2 numbers as roots. But now I'm making an additional requirement. I'm saying not only do I want it to have those roots, I want it to go through the point 1, 5. So 1, 5 is 4/3 is a little bigger than 1, so 1 is probably right there. 1, 5 is way up here. So I'm looking for a parabola that will do something like this. So it's going to be very tall, upside down. It looks pretty. It looks like it's going to be pretty narrow. Okay. Well, what do we know? We know our parabola has to have the following as factors. And you can write this a number of ways, but you could have x minus 4/3 as a factor, and it has to have x plus 1 as a factor. It would have to have those if it's going to go through the x-axis at 4/3 at -1. You should just think about that for a minute. If we're on the x-axis, ask yourself what y has to be. Y has to be 0. So if y were 0 here, you put a 0 in for this y, then you can quickly see if x was 4/3, right? If I put 4/3 right there, 4/3 minus 4/3 would be 0. So that would be 1x intercept, which is what we wanted. There's the 4/3. And then if x were -1, -1 plus 1 would be 0. So that's another x-intercept. So sure, yeah, this parabola definitely has the correct roots. Problem is, I don't know if it's going to go through 1, 5 or not. So what I'm going to do is I'm just going to put an extra number here. I'm going to put a number in front, k. We've already seen what a number can do in front of a parabola, right? When we did completing the square and graphing, we saw that we put a number k in front. It can make the parabola very narrow or very wide. It can make the parabola turn upside down. So all I'm saying is that we pick the right k, then that should happen. Well, since I want to go through the point 1, 5, all I'm going to do is sub that in. Not plugging in 0 anymore. We're going to plug that point in here. So watch what we get. We get 5 equals k times 1 minus 4/3 times 1 plus 1. So let's finish this up. 5 equals k times -1/3 times 2, or 5 equals k. 2 times -1/3 is -2/3. So multiply by the reciprocal, and we get -15/2 equals k. So our parabola is y equals -15/2 of x minus 4/3 plus 1. Now, if you want to, you can multiply this out. You can multiply out these 2 binomials and then distribute the -15/2 into it, and you'll get it to look like this: ax squared plus bx plus c. Okay? So let's discuss just something that might seem like another possibility. So I'm willing to bet, if I asked some people to write a quadratic equation that has 4/3 as a root, and x equals -1 as a root, some people might write this instead. Y equals 3x minus 4 times x plus 1. Okay, so let's pretend you wrote this down to start. Sure enough, that fits the bill. That definitely has the correct roots we want it to have. Okay, let's put a number k in there again, and let's use the same trick. I want it to go through the point 1, 5. Let's finish this. Let's plug in the point here and see what happens. So we get 5 equals k times, if I plug 1 in here, I get 3 times 1 minus 4 is -1. If I plug 1 in there, I get 2. So it looks like this time I get k equals -5/2. Okay, so our parabola now is y equals -5/2 of 3x minus 4 times x plus 1. So if you look at it at a quick glance, you might think, hey, that's a different parabola. Here's the other one, y equals -15/2 of x minus 4/3 plus 1. plus 1, sorry. However, if we look more closely, we realize they did the exact same thing. Take a look at this parabola up here. If we factor a 3 out of that, we end up getting the following. We end up getting 3 times x minus 4/3. So even that's a little strange to factor a 3 out of a 4. You can do it. And then look what happens if you do 3 times 5/2. You get negative 15/2. So people who got answers that were looking different really didn't get a different answer.